Hello again. Remember me, the AI version of Dr. Rania Kalsi? I'm back, still powered by the same generative AI technology you'll be learning about in this course. In this video, we'll take a closer look at the syllabus, the weekly topics, expectations, and grading details that will guide your learning journey in AI 402 and AI 502. In the previous video, you got a glimpse of the amazing technologies we'll explore, from autoencoders and generative adversarial networks to diffusion models and transformers. Now, let's take a closer look at how our journey unfolds, week by week. Your roadmap through generative AI will begin in week 1 by laying the foundation, getting started, and setting up your environment. In week 2, we'll introduce the fascinating world of generative AI, what it means for machines to create, and how these models differ from traditional AI systems. Then, in week 3, we'll take a step back to understand the broader context. An introduction to artificial intelligence and machine learning, so you can see how generative models fit into the larger AI ecosystem. Week 4 marks the transition into deep learning for generative modeling, where you'll explore how neural networks learn complex patterns and representations. In weeks 5 and 6, we move from theory to practice. You'll work hands-on with autoencoders, building them in Keras, a powerful and beginner-friendly deep learning library in Python. And don't worry, you won't need to install anything complex. We'll use Google Colab, an online environment that makes coding and experimentation simple and accessible for everyone. Weeks 7 and 8 take us deeper into variational autoencoders, VAs, models that can generate new data by sampling from learned latent spaces. You'll also implement VEs in Keras, gaining practical experience in how AI learns to imagine. In week 9, we'll pause for a review and the midterm exam, consolidating everything you've learned so far. Then, in week 10, we'll introduce generative adversarial networks, or GNs, a revolutionary idea where two networks compete to create realistic outputs. This is the point where AI begins to demonstrate real creative power. Week 11 shifts our focus to large language models and natural language processing, exploring how transformers can understand and generate human-like text. In week 12, we bring vision and style into play with image generation and style transfer, learning how AI can blend artistic expression with deep learning techniques. Week 13 is dedicated to transformers in AI, the architecture that unites text, vision, and even audio, and the foundation for today's most powerful generative models. Week 14 connects innovation with responsibility. We'll discuss applications of generative AI and the ethical considerations that come with creating powerful, autonomous systems. Finally, in week 15, we'll explore diffusion models, the newest frontier in generative AI, and wrap up with your paper presentation and final exam, where you'll demonstrate both your understanding and your ability to create with AI. By the end of this roadmap, you won't just know how these models work, you'll be able to think like a generative AI designer, connecting algorithms, creativity, and responsibility. And remember, this outline is subject to change, and it probably will, as we adapt to your pace, your interests, and the exciting new developments happening in the world of generative AI. So mainly, this outline, or summary of what we will be exploring during this course, could be found in the syllabus file. This file also contains very important information such as class policies, disability support resources for technical assistance, grading, course objectives, description, textbooks, and much more details. You can go explore the syllabus, but let me go through an important part. The grading. Let's take a moment to go over the grading scale used in the College of Computing here at Grand Valley State University. Like most courses in the college, this class follows a standard percentage-based grading system, but what really matters is understanding what each letter grade represents in terms of achievement and mastery. A score of 93% or above earns you an A, which means outstanding performance. Your work demonstrates exceptional understanding, creativity, and technical precision. Between 90% and 92% is an A-, still excellent, showing a very strong grasp of the material with perhaps a few minor areas for improvement. 87% to 89% is AB+, and 83% to 86% is AB. These reflect good to very good performance, meaning you're consistently strong in your understanding and application of concepts. 80% to 82%, or AB-, means you're on the right track, but could benefit from refining certain details or demonstrating deeper insight in your projects or labs. A C+ or C, from 77% to 79%, or 73% to 76%, indicates satisfactory progress. You've met the core learning goals, but should continue developing your technical depth and problem-solving precision. 70% to 72%, A C-, and 67% to 69%, AD+, reflect minimal mastery. It's still passing, but suggests you may need to revisit some foundational topics. 63% to 66%, AD, represents a narrow pass. Below 63% is an F, meaning the required learning outcomes were not achieved. In short, your grade reflects not only accuracy on exams, but also engagement in labs, discussions, and your ability to connect theory to practice, especially through your CARA's hands-on projects and your research paper presentation. Remember, this course is not designed to test you, it's designed to transform you. Every assignment, lab, and discussion is a step toward mastering the creativity and responsibility behind generative AI. So focus on learning deeply, ask questions, and challenge yourself to explore. The grades will follow naturally. Now, let's talk about how your final grade will be calculated. We actually have two different grading computations, depending on whether you're enrolled as an undergraduate student in AI 402 or a graduate student in AI 502. For AI 402, your grade is built around consistent progress through practice. 60% of your grade comes from quizzes and assignments, which are designed to help you apply what we cover in class. The midterm exam counts for 20%, and the final exam for another 20%, both evaluating your understanding and synthesis of core generative AI concepts. For AI 502, the structure shifts a bit toward research and deeper analysis. 40% comes from quizzes, class assignments, and labs, 20% from the midterm exam, 20% from your paper presentation, and 20% from the final exam. The main difference between the two courses is that AI 502 includes a research paper presentation, a key milestone where you'll explore, analyze, and present a landmark paper in generative AI. For undergraduate students in AI 402, participation in this research activity is optional, but highly encouraged. If you'd like to collaborate with graduate students on their presentations or contribute to the discussion, it can count as extra credit, and it's a wonderful opportunity to gain early research experience. Whether you're in 402 or 502, the goal is the same: to develop both technical mastery and critical understanding of how AI can generate, create, and transform the world around us.